All right, function operations. So we're going to split 6.6 up into two lessons. And the first thing that I want to talk about is a little bit of review. Function operations, and I'm hoping this lesson is really simple. We're just going to be adding, subtracting, multiplying, and dividing. But we're just going to do those things with a different notation. The math isn't going to change. What I want to talk about, though, is the domain. Okay. And for the problems that we have worked with so far, linear, quadratics, rationals, radicals, only two of those really have a domain we have to worry about. Okay, the domain for linear or quadratic, cubic, the domain for any of these, okay, which are just nothing more than polynomials, is always all real numbers. Is negative infinity to positive infinity in interval notation, or all reals. Okay. Well, the domain for a rational, rational function, rational again meaning fraction, the thing we have to worry about is when I have a zero in the denominator. Okay. So I cannot have 0 in the denominator. I'm actually going to switch slides here. I'm going to run out of room. Okay. So again, the domain for any polynomial is always all real numbers. For a rational function, I'm going to put a different example here, which is 1 over x. Okay. We've got to ask ourselves, what number will make the denominator equal to 0? Okay, this right here, that's the value we can't plug in. So that's what does not exist in the domain. So for this problem and to solve it algebraically, we just set the denominator equal to 0. Okay, so to find this value, we set the denominator equal to 0 and solve. This is the value. This is the value the denominator cannot be. I'm going to show you a couple of examples. Okay, so this one, very simple. You just set x equal to 0. Well, I'm telling you x cannot equal 0 because if I plug it in here, and if you plug it in the calculator, it's going to tell you error. So the domain for this would be negative infinity to 0. That's a really bad infinity. Okay, and then it starts back up at 0 and goes to positive infinity. So what if I gave you a problem that looked like this? 5 over 3x plus 2. Okay, so if I'm asking you to find the domain, I'm asking you to look for what number will make the denominator equal to 0. So what I do is I set 3x plus 2 equal to 0. I subtract 2. 3x equals negative 2, divide by 3, and I get x is equal to negative 2 over 3. So the domain for this would be all real numbers except negative 2/3. So I just put this in interval notation, okay? Negative 2/3 to positive infinity. Now, again, remember what the parentheses means. That just means that it's not included in those values. Okay, the other thing that we have to worry about is a radical expression. Okay, a radical expression with an even index. Okay, and what I mean by that is if I have the square root of x, x cannot be negative. Okay, but if I have the cube root of x, the domain for any odd index is all real numbers. Because, right, what's the cube root of negative 8? Well, that's equal to negative 2 times negative 2 times negative 2. So that would just be negative 2. I'm allowed to have, if I have an odd index, I can have any number underneath the radical. It's just all real numbers. But if I have an even, if it's negative, it doesn't work. That's where we came up with the imaginary numbers. So to find the domain for radicals, we just can't have negatives underneath an even indexed radical. Okay, so again, we do the same thing. We set it equal to 0, but then we see which would make, okay, so then plug in to see which set of values are negative under the radical. Okay, so if I gave you an example like this that said x squared plus 5x plus 4, okay, we're trying to find what values would make this equal to 0. Actually, I'm going to do a little easier one to start. Okay, how about just an x plus 3? Okay, so I do the same thing. I said x plus 3 equal to 0. I subtract 3. I get x is equal to negative 3. This is not my domain. That's the edge of my domain. I need to check whether the values to the right of negative 3 or to the values to the left of negative 3 would make this equal to a negative value. And hopefully the numbers are easy enough to plug in. If I plug in a negative 4 plus 3 is negative 1. I can't have a negative 1 underneath the radical. So this would be all real values starting at negative 3 and we'll go to positive infinity. Okay. So again, if I had a problem that looked like this, negative x plus 3, okay, we would set negative x plus 3 equal to 0, subtract 3, negative x equals negative 3, divide by negative 1, and you would get x is equal to positive 3. So again, now I would check to see to plug in. Well, if I plug in 4, right, values greater than 3, the next value would be 4. Negative 4 plus 3 is negative 1. So this would actually be negative infinity to 3. And again, we don't include, or we can include the 3 here because I'm allowed to have 0 underneath the radical. So there's going to be some problems that ask you about the domain. We're going to do a couple of those, but I just wanted to refresh. We really only have to worry about the domain on a fraction or on a radical expression with an even index. So let's take a look at what we're talking about here with function operations. So you're going to be given functions that are labeled as f of x or g of x, and this is just to show you that if there's a plus sign between them, I'm just asking you to add the two functions together. If there's a subtraction sign between them, I'm asking you to subtract the two functions together. Multiplication, I'm asking you to multiply, and division or fraction, I'm asking you to divide. Now, sometimes you can't even do anything. Like I can't multiply a radical times a number. I can just set them next to each other. So there's actually no math to do. So I want to look at a couple of examples, and this is just kind of the different notation right here. Okay, f plus g is the same thing as f plus g in parentheses of x. This does not mean x times these, okay? This is how I like to write it, f of x plus g of x. So right here, I'm explaining to you what f of x is. F of x is 4x plus 7. G of x is the square root of x plus x. So I want you to find what f plus g is. So the first thing I'm going to do is I'm going to add. Okay, so this is f of x plus g of x. That's what this means right here. So what is f? F is 4x plus 7. What is g? G is square root of x plus x. So all I'm doing is writing these things out, right? I'm adding these two together. Well, what are my like terms? These two right here. Can I add anything else? And the answer to that is no. So I've got a 5x plus 7 plus square root of x, and I'm done. Okay, now what's the domain? Well, with 5x and the 7, I don't have to worry about it. It'd be all real numbers. But because I have the square root here, I've got to ask myself what number would make the denominator equal to 0. Okay, because I can't have a negative. Well, that would be 0. And obviously the values to the left of 0, which are negative, would make this a negative underneath the radical. I can't have a negative underneath the radical. So it'd be, domain would be 0 to positive infinity. Because if I plug a negative in here, it'd be a negative underneath the radical. It would give me imaginary numbers. Okay, so this one, f of x minus g of x. Now pay attention here. When I do f of x, I got 4x plus 7. I'm subtracting the entire function g of x, which is square root of x minus x. This minus sign gets distributed. I didn't have to worry about this with the plus because when I distribute a plus sign, nothing changes. But here, I've got 4x plus 7 minus square root of x plus x. So when I subtract, oh, what am I doing here? Hold on. That's a plus sign. Sorry, this is a plus sign. So when I subtract, that becomes a minus. So 4x minus x is a 3x plus 7 minus the square root of x. Okay, so again, same thing for the domain. What makes this 0? And simple problem, it's 0. And what values would make it negative? It's any number less than 0. So the domain would start at 0 and go to positive infinity. All right, let's take a look at another problem here where I'm asking you to multiply and divide. Okay, so this f times g means f of x times g of x. So f of x is x squared minus 9. G of x is x plus 3. So I'm going to go ahead and multiply. How do I multiply? A FOIL. I get x to the third. I get plus 3x. I get a minus 9x. And I get a minus 27. Nothing left to do with this. I'm not asking you to factor it. I'm not asking you to do anything else with this. But notice I have a cubic polynomial. What's the domain? Negative infinity to positive infinity. Okay. This problem here, f of x over g of x would be x squared minus 9 all over x plus 3. Okay, and I'm happy if you leave it like this. When we get to chapter 8, we'll do a little bit more with this. But what's the domain? I have a fraction now. And what's the problem? I can't have a 0 in the denominator. So I've got to ask myself, what value would make x plus 3 equal to 0? Well, if I subtract 3 from each side, negative 3. If I plug in a negative 3, it would give me a 0 in the denominator, and it wouldn't exist. So the domain goes from negative infinity to negative 3. Okay, I can't plug in negative 3, but I can plug in the next value greater than negative 3 all the way up to positive infinity. Okay, so multiplying and dividing, you literally just do what it says. I think I got one more example here. Nope, I don't. Okay, like I said, sometimes you don't do anything with these problems. So I want to look at, let's see, now we're going to save all this stuff for B. Okay, so let's take a look at a couple homework problems just so you can see right here. Okay, so it says find the domain of x. So what do I have here? In this problem, I like it because I actually have both, right? I actually have both. I can't let the denominator equal 0, and I can't have a negative underneath the radical. Okay, so what do I need to do? I need to set the denominator equal to 0. All I'm doing is find the domain here. Set the denominator equal to 0. So I'm going to set 6x plus 6 equal to 0. Subtract 6. 6x equals negative 6. Divide by 6. And I get x is equal to negative 1. Okay, so I know I can't plug in a negative 1 here. Because if I plug in a negative 1, it's going to make it 0. Also, because it's a radical, I've got to check which values would make this negative underneath. Well, let's see. What's the next value to the right of negative 1? It's 0. If I plug in 0, what's 6 times 0? 0. 0 plus 6 is 6. It's an ugly number, but I'm allowed to have the square root of 6. What about the numbers to the left of negative 1, like negative 2? If I plug in a negative 2 here, 6 times negative 2 is negative 12. Negative 12 plus 6 is negative 6. Am I allowed to have a square root of negative 6? And the answer to that is no. So the domain for this problem starts at negative 1. How did I get negative 1? I just set the denominator equal to 0. It's all values that are greater than negative 1, but not equal to. So any value to the right of negative 1 would work here. Okay, so again, going back to the homework just to make sure we remember how to put that in there. Okay, answer type interval. Okay, I just want to leave it as interval, and it's going to be parentheses, negative 1 to positive infinity. Okay, so you're going to have a few problems like that to work with. And again, this one, there's no square root, so I just set the denominator. Notice I don't ever mess with the numerator. Okay, don't ever set with the numerator. So you don't got to worry about it because that's going to be a linear or a quadratic or a polynomial. So just the denominator is what we have to worry about. All right, go ahead and give that homework a shot. I hope you guys are having a good day.